Hi, I'd like to welcome you today to our presentation on the 5 overarching big ideas that support good mathematics instruction. My name is Dinah Brown. I've been an educator for over 37 years. I recently retired and I joined San Diego State University as the co-director of the CGI Professional Development Collaborative. San Diego State University's Cognitively Guided Instruction Professional Development Collaborative is supporting school districts and charter schools all throughout San Diego County to train their teachers in cognitively guided instruction, or as we like to call it, CGI. This is a body of research that spans decades and looks at students' understanding of mathematics and how to best support our teachers in developing their students' ideas about mathematical thinking. Teachers who have received this training demonstrate a greater understanding of children's thinking, a greater ability to attend, interpret, and respond to student thinking, and are more able to adapt mathematics instruction to meet your individual child's needs. Students in classrooms where instruction is based on conceptual development show significantly higher levels of achievement in problem solving, deeper conceptual understanding, higher student achievement and engagement, linked to many varied, rich opportunities to describe their thinking and reasoning. So you may be wondering, what will math look like for my child? Whether your child is physically attending school on campus or in a distance learning environment, there are many ideas that teachers are implementing in order to provide the most effective math instruction. However, research reveals there are 5 overarching ideas found in classrooms with the best mathematical practice. These ideas are important not only for our littlest learners, but all the way up to our high schoolers. So let's take a look at our first overarching idea. I want you to think for a moment. Do you think a 4-year-old could solve this problem, 3 divided by 2? Let's watch Reese. She's a 4-year-old kindergartner solving this problem.
So Reese, you and I are going to get to share some cookies. You like cookies, right?
Mm-hmm.
So what kind of cookies you want to share with me?
You mean the flavor?
Yeah.
Ow! What kind do you like?
Chocolate chip.
Chocolate chip.
Okay. So if you and I are going to share 3 big chocolate chip cookies, how much cookie can you have? How much cookie can I have? If we share it equally, fairly, how much cookie can we both have?
You get that side, I get this side.
Okay.
Same thing.
I think so. How much cookie do I get?
You get the top, and I get the bottom.
Bottom. And do you know how much, if I get this top part right here, do you know how much of the cookie I get? What would you call that size piece?
A half circle.
A half circle, half the cookie?
Mm-hmm.
Hey, so how many halves do I get?
You mean
Altogether, how many halves do I get?
3?
I get 3 halves?
On the top.
And you
I
get
get the bottom 3.
Many of you were probably surprised with how successful Reese was with the problem. 3 divided by 2 is a division problem with a fractional answer, typically a 5th grade topic. But Reese was able to successfully draw a model and describe the total amount, 3 halves, that one person would get. What allowed Reese to be so successful? Research shows us that context, a story, helps all students gain access to mathematics. Story problems help build upon students' informal mathematical experiences as they make sense of their world at home, school, and around them. For example, in a landmark research project by Tom Carpenter and his colleagues, 86% of 70 kindergartners in CGI classrooms had a valid strategy to solve 3 times 6 when the problem was presented in a context, such as a word problem. Robin has 3 packages of gum. Each package of gum has 6 pieces. How many pieces of gum does Robin have? This brings us to the first of our overarching ideas for the best mathematics instruction. In CGI classrooms, you will see most of your child's mathematics instruction come in the form of word problems. We believe word problems provide students more access to mathematical concepts, including computation, while allowing for deeper conceptual connections and problem-solving skills. Let's talk about the second overarching idea. Our goal is to develop mathematicians. We believe math is more than just following directions. Students who develop their own mathematical ideas, not just learn to follow a set of procedures and steps, will have greater understanding. Let us show you a little about what I mean here. Let's meet Javier.
You know how eggs come in a carton?
Yeah.
And there are usually a
12,
dozen? There are
yeah.
12 in there. How many eggs would you have if you had 6 dozen? So if you had 6 of those.
Okay, let me see. 6 times 12. That will be... 72. Because when I say 5 times 12, that equals 60. If I add 12 more, it will be 2, 7.
How did you know that 5 times 12 is 60?
Because 12 times 10 equals 120. If I take the half of 120, that will be 60. Can go there. So I go 6.
Wow, great explanation. What if you had 12 dozens?
12 dozens.
Right.
That will be 12 times 12. And 32. 144.
And how did you figure that out?
Because I knew that 12 times 10 is equal 120. If I added 24 more, because 12 times 2 equals 24, I go like 120 plus 24. That will be 4, 4, 1. Number 4.
Great job.
As you can see, Javier was able to efficiently solve the problem 12 groups of 6 by using a strategy based in his understanding, not a procedure taught to him. If we look at the mathematics involved for Javier's strategy, we can see that his understanding is deep. He understands the distributive property of multiplication, the substitution property, the associative property of multiplication over addition, and has amazingly strong place value understanding. These are all ideas that come from Javier, not from a taught procedure. Student developed strategies, both concrete and abstract, lead to rich understanding of place value and the properties of operations. Research shows that early introduction of taught procedures diminishes student understanding. As a part of the best math instruction, focusing on student thinking, instruction in taught procedures is very purposefully placed. Addition and subtraction algorithms are not formally taught until 4th grade. Multi-digit multiplication algorithm is not formally taught until 5th grade, and the long division algorithm in 6th grade. Acceleration of instruction in algorithms does not accelerate understanding, and in fact, can undermine development of student understanding of place value and their usage of the property of operations. The research is clear. Student developed strategies, both those that are concrete and abstract, will lead to greater understanding. Our third overarching idea for the best math instruction deals with mathematical tools. You will see your child using tools. The best math instruction celebrates the use of these tools. The use of math tools supports student understanding and the development of sophisticated strategies for all age groups. These tools can span from counters and fingers in the youngest learners to place value blocks and sophisticated drawings or models as a child's understanding develops. Research finds that mathematical tools can help make abstract concepts more concrete and understandable, allow students to access problems out of their reach otherwise, like we saw with Reese, helps develop their confidence and flexibility, and it does not limit student understanding. Rather, the use of tools can lay a solid foundation for the development of more efficient and abstract strategies. They won't use tools forever. Our fourth overarching idea, talk about it, mathematical discourse. The best instruction in mathematics should revolve around mathematical discourse. Research shows that children who regularly engage in mathematical discourse have higher levels of engagement in mathematics and deeper understanding. Your child may be asked to describe and explain their thinking, and will be asked to listen to their peers and engage in others' ideas, comparing their ideas, summarizing, and evaluating their reasoning. As a parent, instead of showing your child your way to solve a problem, you might ask some of these questions after your child solves a problem using their own understanding. You might ask, "Tell me about your thinking. How did you know that? Tell me about your strategy. How did you solve this problem?" This fourth overarching idea really speaks to the goal of growing children as lifelong learners, an asset they will carry with them forever. Finally, our fifth overarching idea, productive struggle. We value productive struggle. The idea that some challenge is good as an important part of our math instruction. Strong math instruction should not focus only on tricks to make math easier. We resist the temptation to teach tricks, thereby eliminating struggle. We believe that productive struggle is beneficial both to our children as learners and to our children's mathematical understanding. Carol Dweck, author of Mindset, describes productive struggle as a gift parents give to their children. To teach your children to love challenges, to be intrigued by mistakes and enjoy effort. For example, when your child solves a difficult math problem, try saying, "Wow, I see how hard you worked on this difficult problem," versus, "Great job, you're so smart." Embracing productive struggle, exposing our children to challenges, and resisting the temptation to just teach them tricks that do not build on understanding will build their independence, their agency, their self-efficacy, authentic understanding, critical thinking, and help students to be less prone to crippling frustration. Please keep these 5 overarching ideas in mind when working with your child. Word problems help to develop their understanding, to let student understanding lead the way, to celebrate mathematical tools, encourage mathematical discourse, and to embrace productive struggle. Good mathematicians must make mistakes and revise their ideas. We hope you found this video helpful. Here at San Diego State University, we look forward to providing ongoing support to teachers, students, and families. I would like to leave you with these 2 thoughts. First, encourage your child to think mathematically. and for you to be curious about their thinking. Thank you for joining us today.